Hello everyone, welcome to Leeds PHP. This month we have Thibault who will talk to us about a practical guide to a PHP serverless application. The talk will last about 45-55 minutes. We'll have some questions at the end, and then around 8 o'clock we can hang around for a chat. Our broadcasting platform is Big Jar Orange Art, and their aim is to support and promote well-being and mental health within remote working communities. We have a Slack, and this is the link. We'll also show it again at the end, just to make sure that if anyone is interested, they can sign up. So yeah, welcome and enjoy our talk for November.
Hi, everyone.
Hi, it's nice to have you.
Nice to be here.
All right, looking forward to your talk.
Yes. Okay. So, thank you everyone for coming tonight. So, my name is Thibault. I'm currently working at Wid'op, which is a French company based in Lille, in northern France, and we are doing a client projects using Vue.js, Symfony, and mainly AWS. And so my work here is so I'm a backend developer working with mainly Symfony, and I'm also for the past 2 years I've been doing a lot of DevOps work using AWS and mainly in the AWS. And so tonight I will talk about a practical guide to PHP serverless applications. And so the goal of tonight is to deploy the Symfony Demo app inside AWS using serverless technologies. But you might be wondering, what is serverless? Well, serverless is about managing less infrastructure. So some key characteristics of serverless architectures and serverless services is that it has infinite scaling built in, automatic infinite scaling, which means that the cloud provider you are using should be able to handle the load, the scale. And so if you have 1,000 requests, it should be able to handle 1,000 requests. If you have 10,000 requests, it should be able to handle them for you without you needing to configure thresholds about how you scale and when and to how much. It's just built in. And this also means that you can scale to zero. If your application is used like Monday to Friday and not on the weekends, not on the nights, then your application might just scale to zero and there is no traffic. You just don't scale. There's nothing running. And because of that, another characteristics is that you pay per use and not for uptime. So if you have 1,000 requests, you pay 1,000 requests. If you have 10,000 requests, you pay 10,000 requests. It's also highly available and fully managed by your cloud provider, which means you don't have to care about the operating system, you don't have to care about the networking, the security, about provisioning servers and doing backups and doing failure recovery. All of that should be managed by your cloud provider. And you could trust them in doing a better work than you would if you did it yourself. And a common example of a serverless service is AWS S3, which is which is a file storage service. So you can send files to AWS S3, retrieve them, and you pay only for what you use. So you don't have to provision disk and doing backups again. That is done by AWS for you. And if you have 1 megabyte of data in AWS S3, you pay for 1 megabyte. If you have 1 terabyte of data, you are paying for 1 terabyte. And other services outside of AWS are things like Auth0 for authentication, or Algolia, which is a good candidate to replace an Elasticsearch instance, for example, or Netlify to host static websites. And one particular service that is really interesting for us developers is AWS Lambda. AWS Lambda is a serverless compute service, and that means you just have to bring your code, and AWS will figure out the way to run it, to execute it. And it's called an event-driven service. That may sound a bit scary, but you're probably already doing event-driven, using event-driven, because an event could be an HTTP request. So a user makes a request, AWS Lambda processes the request, executes your code, returns a response. And it's like auto-scaling at the request level. So one request comes in, it's executed in an isolated environment. If there are 10,000 requests coming, they are each isolated in a different environment, executed. And we can visualize this like this. So you have a user making a request. It creates from scratch a Linux environment, executes your code, handles the request, returns a response, and then the environment dies. If you have 3 requests at the same time, 3 different isolated Linux environments are booted, handles each their request, and then die. Well, that's not exactly true. Actually, when there is a request coming, yeah, AWS Lambda is creating a Linux environment from scratch. But then it keeps it in some kind of cache for about 10 minutes. And so on the next request, this Linux instance will already be ready to handle new requests. But if you have more requests than there is Linux or Lambda instances in the cache, then it will boot new Linux environments and then store them in cache so that the next request will be served from cache. And so when AWS Lambda is creating a new Linux environment, it takes a bit of time, and that's often referred to as cold start. So a cold start is where AWS creates a new Linux environment. It takes a bit of time, and for PHP, it's about 250 milliseconds. So that's added latency, but on production workloads, it represents less than 1% of actual requests. And it gives you these awesome capabilities of infinite scaling. Okay, so now that you have an idea of what serverless is about and how AWS Lambda works, then we can start hosting the Symfony Demo serverlessly in AWS Lambda. The first thing we need to do is create a new Symfony Demo project. So we run Symfony new -- demo, Leeds talk, for example. That's the name of the folder it will create, and it creates a Symfony Demo project. And I chose the Symfony Demo because it's a complete project. So it will give us a good idea of how to host a full-blown website in AWS Lambda. So it uses Symfony, it uses Twig, so to render HTML, a database, it has users and sessions, it uses Webpack Encore to compile assets, it has console commands and many more things, and it's also self-contained by default, which means we don't have to compile the assets, and it comes with a seeded SQL-like database, so with all the tables and data in it, so that's nice to get started. All right, now that we have our Symfony Demo project, we can install Bref. And Bref can be installed running composer require Bref Symfony Bridge. So this will install those 2 libraries. But you may ask, what is Bref? And Bref provides PHP runtimes for AWS Lambda because out of the box, AWS Lambda doesn't support PHP. It supports JS, Go, Java, Python, but not PHP. And so Bref provides a custom runtime for AWS Lambda to be able to run PHP applications inside AWS Lambda. But it's really built like a native AWS runtime. And it also provides helpers to integrate with AWS services. It provides deployment utilities, framework bridges like the Symfony bridge we just installed, but also there is a bridge for Laravel, for example. So if you're using Laravel, that this whole presentation should work almost the same. And it also provides loads and loads of documentation. And one nice thing about the Bref documentation is that it's written from a PHP developer perspective. So you should really feel at home when browsing through the Bref docs because it has everything you are searching for as a PHP developer using serverless. Okay, now that we installed Bref, we need to do a few config tweaks. So first we need to change. So here we are in the kernel.php file, and we need to extend the Bref kernel instead of the base kernel. And that will, because there is one constraint inside AWS Lambda, is that the file system is read-only. And Symfony by default writes file into the var cache folder. And because the file system is read-only, that wouldn't work. And so the Bref kernel moves the var cache folder inside /tmp, which is the only folder writable on AWS Lambda. So Symfony can work like it always did inside AWS Lambda. Then we need to add those few lines of config in framework.yaml. That's just to tell to tell Symfony to read those headers, so X forwarded headers, to be able to generate URLs properly. So you can you have the X forwarded shim, X forwarded proto, which is, for example, saying to Symfony to generate URLs in HTTPS instead of HTTP. And then the last thing we need to do is to configure monologue to write the errors, so the logs, inside PHP SCDERR. And these logs will actually be forwarded to another AWS service called CloudWatch Logs, which will allow you to browse and search through your logs. And again, because the file system is read-only and it's ephemeral, its Lambda instances are isolated from each other, then it wouldn't make sense to write those logs on the file system, right? So you just have to change this config in monologue. Okay, so we did the few config tweaks, and now we need to take a moment and talk about the serverless framework. The serverless framework is a deployment framework. It's not a web framework like Symfony or Laravel. It's only caring about deployment. So it's a framework that is configured through a file called the serverless.yaml file, which will extensively describe our infrastructure. And its main focus is about simplifying the configuration and deployment of Lambda functions. And one nice thing is that the Symfony bridge for Bref is coming with a flex recipe, a Symfony flex recipe that will create a default serverless.yaml file that is tailor-made for Symfony applications. And so this file looks something like this. I removed some parts, but the idea is the same. And we'll go through a bit of this config to figure out what's going on here. First, we have the service key here. And you want to make sure to change this key because this is the way this Symfony value here will be in all the resources created by serverless framework inside AWS. So you have to make it something relevant. Tonight, because we are at Leeds PHP, I chose Leeds Talk blog because Symfony Demo is a blog. But yeah, just choose something relevant so that you can figure out quickly what those resources are about when browsing through the AWS interface. Then we have the provider key, which says first name AWS. This is because the serverless framework can deploy to multiple clouds like Google Cloud or Azure, but Bref is only compatible with AWS, and we are going to use AWS tonight. So we say AWS, then the region. Here it's US East 1, and you want to choose probably a region that is closest to your user base. So again, we are at Leeds, we are in the UK. So I chose the London data center, which is EU West 2. Then you have a stage. This is like an environment for the serverless framework, and you don't really have to care about that for now. Then we have the runtime, which is provided. This just says that because the runtime is a custom runtime, it's Bref that is providing the runtime for PHP. We are saying it's provided by Bref. And then we have the environment key, which says appenv prod, and we can define many environment variables that are required by our application. Then we have a plugins key. That's just the Bref plugin for the serverless framework. It allows Bref to hook into the deployment process and do some things. You don't really have to care about it either. And that's where the fun begins. We have the functions key. And here we are defining all our Lambda functions. So here we are declaring a web function, and then we have these events. So as I said, Lambda is event driven, and here we are saying it's triggered by an HTTP event. And the star character you see here just means it will handle all the requests. So all the methods and all the paths will be forwarded to this particular Lambda function. So if you hit get slash or get slash hello world or post slash users, then all of this will come to this single Lambda function. Then we have the handler, which is public index.php. This is the main entry point in any Symfony application. And again, this is quite similar to what we are doing in a server-based infrastructure. We are saying, take all the requests and forward them to index.php. It's similar to like a rewrite rule in with Apache, for example. And then we have the layers key. Here we are just loading the Bref runtime. So it uses PHP 8.0 FPM. So it's actually running PHP FPM version 8.0 inside AWS Lambda. And so you have a very familiar environment inside AWS Lambda. You have PHP FPM. All the requests are forwarded to the index.php. So you almost feel at home right now, right? And then you have the timeout. And the timeout is just a constraint we have inside AWS Lambda. When running HTTP request, we have a timeout, a maximum timeout of 28 seconds. And that's not configurable. Can't go any further. All right, so we have this old file, this old serverless framework config file. And now you can just run serverless deploy. And this will compile this serverless.yaml file into instructions for AWS to create the required resources that matches the configuration you gave in serverless.yaml. And you probably want your deployment script, if you'd like, to look something like this, where you first optimize Composer for production. So you remove the dev dependencies and you optimize the autoloader. And then you warm up the Symfony cache for the production environment. Then you run serverless deploy so that your application is packaged to run in a production fashion. And when doing serverless deploy, you should see logs like this. This is the serverless v3 output style. So if you are installing the serverless framework right now, it may not look like this. But yeah, this is just the beta preview, and it's much cleaner. So hope this will come out soon. And so here it's saying deploying Leeds Talk blog to stage dev in EU West 2. So that's what we saw in the service and provider key just before. Then it's saying a bunch of things. It says it took 241 seconds to deploy the service. And that may seem huge, but it's just because I have a very poor internet connection at home. So when I uploaded the code to AWS Lambda, it took like half of this time is just upload time on my end. And it gives us this wonderful URL, which is our website URL. So our current infrastructure looks something like this. Our users make, like in their browser, make a request to our API gateway. And API gateway is the service that is handling HTTP requests when using AWS Lambda. And it forwards all the requests to AWS Lambda, and it runs the public index.php file. But if we click on this link and open it in a browser, we see something like this, which, let's be honest, looks awful. And that's because assets are not loaded. And they are not loaded because you don't want to serve assets from AWS Lambda, because you would suffer also cold starts on assets, and it would be highly cost inefficient. So we need an efficient and reliable way of delivering assets. We want these assets to be as close as possible to our users, and we want these assets to be cached at edge so that it's really, really fast to load them. And so we need to deploy a content delivery network, a CDN, for our assets to be handled, to be served to our users. And so to do this, we need to install a serverless plugin that's called Serverless Lift. So we just run serverless plugin installation and serverless lift. This will do this plugin. And Lift is, so yeah, a serverless framework plugin, and it's an abstraction layer for AWS infrastructure. So that means you don't really need to know what's behind the scene. It abstracts it for you, and it abstracts it in the same way the serverless frameworks actually abstracts it from you. And one nice thing about Lift is that it's focused on use cases and not infrastructure. You say to Lift, I want a storage, I want a queue, I want a website. You don't need to know by yeah, it's just really focused on the use case and not the actual underlying infrastructure. Even though you need to care about it, it's not thought from an infrastructure perspective. And so for our case, where we need a CDN to serve our assets, so the serverless install command registered the serverless lift plugin, and then we can declare a new constructs key inside our serverless.yaml file, which is of type server-side website. And that will deploy the CDN for us and upload the assets that are listed below. And this list is a mapping between the actual path the user will request and the files that are uploaded to the CDN. So when a user requests /build/app.css, for example, it will serve the file that is currently located in public build app.css. And public build is where Webpack Encore stores its file. And then we have also the favicon and the Apple Touch icon and the robots.txt. But those files will be served from the CDN, and all other requests will be handled by our Lambda. And one more thing we need to do is that we need to exclude assets from the Lambda deployment. And it's done out of the box by the serverless.yaml file provided by the Symfony bridge. So here we are just excluding a bunch of folder like assets, non-modules, test, var, etc. And then we are including back some files that are required. So because previously we pre-warmed the Symfony cache, we are actually including back the var cache prod folder, and those two other files are needed by Webpack Encore to generate assets URLs. All right, and then we run serverless deploy again. And this outputs something like this. So I truncated the output a bit, but it should look something similar to this, where it's saying at the middle here, uploading those JS and CSS and fonts and SVGs and things like that to our CDN. And then it outputs the website URL, which ends in cloudfront.net here. So that's really important. The URL we used previously, which is still at the bottom here, we won't use this URL anymore. We will use the cloudfront.net URL. And our current infrastructure looks something like this. So we have our users sending requests through CloudFront. And then if the requested path matches one of the expressions on the top here, so build star or favicon.eco or Apple Touch or robots.txt, then it will serve them from a S3 bucket directly to our users. And if it doesn't matches one of those paths, then it would forward the request to API gateway, which in turn will forward the request to AWS Lambda, execute our public index.php, return a response. And this is Symfony doing its job. And while the infrastructure may be different, this should look familiar again, because that's almost how Apache or Nginx are working. It first tries to retrieve a file from the file system, and if it doesn't match, it rewrites the request to the index.php file. Symfony handles the routing, processes the request, returns a response. So here we are again in a pretty familiar workflow. And now our website looks pretty good. This is how it's supposed to look when running the Symfony demo. Okay, so we have assets. We have a URL for our website, which is already pretty nice. Symfony is executing, rendering HTML. But what about the database? Because as I said earlier, we are still running a SQLite database right here. And because the file system is read-only, again, it's not writable. We cannot write to this SQLite database. And even if we could write, because those Lambda instances are isolated from each other, and they are deleted on a regular basis, and there is no state shared across those concurrent Lambda instances, we wouldn't want to write to the SQLite database, which is in memory. So we need to run something like MySQL or PostgreSQL or MariaDB. And again, here, Lyft provides a construct. So we say database, type database SQL, because Lyft also supports NoSQL database. And here I chose PostgreSQL, but you could also say MySQL or MariaDB here. And I'm giving it a password. And because I don't want to commit credentials in Git, the password is retrieved from an environment variable. So locally, you have to export this variable, or you can add this variable in a CI/CD pipeline, for example. And then we add an environment variable, which is database URL, and we inject a dynamic variable here, which will be replaced when deploying by something that looks like Postgres column //user column password at host /database name. And this is what Doctrine expects by default, and many other SQL clients are supporting this format. You can also retrieve the host, the password, the username, etc. directly, but this is just a nice shortcut. For full disclosure, this particular construct here, the database SQL construct, is still work in progress, so it's not available right now. But of course, we are hoping to release it soon. And the last thing we need to do before deploying is enable the PDO PGSQL extension. So here we are creating a php/confd/php ini file, and this is a classic PHP ini file. So you can configure anything here, and we are just enabling the PDO PGSQL extension. So Bref comes packaged with a lot of extensions by default. Some of them are disabled by default, like PDO PGSQL. And you can, of course, configure more ini stuff here. So you can add the time zone, for example. And then we run serverless deploy, and it starts to get boring, right? That's too simple to deploy. Well, apparently not so boring, because after the deploy, we have a 500 errors on our website. So we broke everything. And this is, well, because this is a 500 error, we want to see the logs. We want to see what went wrong. And as I said earlier, logs are written inside CloudWatch logs. And the serverless framework comes with a nice command, which is serverless logs, which allows us to see the logs of a Lambda function, here the web function. And the log says undefined table relation Symfony Demo post does not exist. And of course, that's because we need to execute migrations after deploying. Before we add the SQLite database that was coming with tables and with data in it by default, now we need to create them and execute them after each deploy so that our database schema is up to date. And one thing I didn't mention earlier for the sake of simplicity is that, yes, the serverless.yaml file that comes by default as a web function, but it also has a console function, which allows us to run console commands inside AWS Lambda. And so here the handler is bin console. It should be artisan if you're using Laravel. And it uses the PHP 8.0 layer, not the FPM one, because it's PHP CLI, if you'd like. And then the console layer. Then we have a timeout of 120 seconds. That's configurable. You can go up to 15 minutes on this kind of processes. And then our deployment script should now look something like that. We run the serverless deploy the code inside AWS Lambda, then run vendor bin Bref, which is a CLI provided by Bref. So vendor bin Bref CLI, the name of the function that was deployed. And as you can see here, it contains the service name, the stage name, and the function name. All of that separated by dashes. And then we say dash doctrine migration migrate to execute the doctrine migrations. And so when doing that, it works again. Now we have a fully working database, and I just added an article for the sake of the example. But yeah, we have a fully working PostgreSQL database that is hosted inside AWS with 3 lines of YAML. That's pretty neat. And we are done. Like, we deployed our code, we served assets from a CDN, we created a database, and we executed the migrations. Your application doesn't need more, right? All of our applications are just CRUD applications that don't do anything more than just write and read from the database, right? Huh. I know it's not right. It's not how we build applications today. We have sessions for our users. We use queuing. We use HTTP cache like Varnish. We run cron jobs because we need to do some batch processing during the night, for example. And we need dev and staging and prod environments to do to fit with our development lifecycle. And of course, we don't want to keep those CloudFront.net URLs. And I'd say, how about we do all of that right now? So I'll start to get, I'll go a bit quicker, but we'll do all of that. So first, you are using sessions. Again, the file system is read-only. You don't want to write sessions in the file system. So you need to store them in a shared store like a database or a Redis or a DynamoDB table, which is a NoSQL database provided by AWS. And so here I chose just to deploy, to store them in the Postgres database. So Symfony has built-in support for this. We just need to declare a service, give it the database URL, and then we configure the framework.session.handler ID with the handler we created just before. So we create a handler, we register the handler service, and then we pass it to the session. We say it's the session handler, and Symfony will just store the sessions in the database. And you need to also add a migration with the table, of course, but all of that is documented and is pure Symfony feature. Okay, and now you want to use queues because you don't want, for example, your users to wait when you send an email. You don't want to add extra latency to your website because you're sending an email, so you want to send emails asynchronously. Well, you first install the Bref Symfony Messenger bridge. So Composer require Bref Symfony Messenger. And again, Lyft comes to the rescue and has a construct for queues. So this will create production ready with baked in best practices. So queues with best practices built in. So here we say type queue alarm. I'll just get to that in a moment. And then we have this worker key where we say it's handled by bin consumer.php, like we said, public.index.php. And again, this file, I'll come to it in a second. We have our timeout, fully configurable, still the 15 minutes limit, and the PHP 8.0 runtime layer. All right, and we then need to say messenger transport DSN. So this is the default environment variable used by Symfony, which will be again resolved by Lyft when deploying. And so the deployed queue looks something like this. So on the left, you have your application sending new messages to the queue. SQS is the queuing service in AWS. And in a traditional approach, you would have to run a bin console command. So I think it's something like bin console messenger consume, which would poll the queue. So regularly check if there are new messages in the queue and run the logic associated with those messages. When running serverlessly, you don't have to manage anything. And so this polling feature is built in. There is an integration between SQS and Lambda so that whenever there is a new message in SQS, it will trigger a new Lambda function that will handle the message. And it will do this. If it fails, it will put back the message in the queue. And if it fails more than 3 times, it will be forwarded here at the bottom to what we call a dead letter queue. So a dead letter queue is another queue where we store messages that failed too many times, and it's just for us to be able to debug this. So Lyft has also commands you can run to list those messages and see what's wrong with them, and to retry those messages to put them back in the main queue. And here we see we have an alarm, and that's because, so previously I added alarm thibault@wid'op.com. And so whenever there is a new message in the dead letter queue, I will receive a message so that I'm informed that there is an error, a message that failed, and that I need to take a look and see what went wrong. And so, yeah, we don't have to manage anything. If there are like 1,000 messages in SQS, it will just simultaneously trigger 1,000 Lambda functions that will handle each one message. And so that's pretty nice. We don't have to scale workers. It's done for us automatically. And if you need to say like, I only want like one worker or 5 workers at the same time, that's configurable too inside the serverless framework. And here is our bin consumer.php file. This is straight from the Bref documentation. It just creates a Symfony kernel, boots it, and then retrieve a service, which is the SQS consumer provided by the Bref Symfony Messenger bridge. So yeah, that's just a file provided by Bref. You don't really have to care about this. And then we configure Symfony Messenger. We say it doesn't have to do the auto setup because we just created the queue, so there is no need to create it. And the routing here, so we are saying we send our emails asynchronously. So this is a message sent by the Symfony mailer component, which says that when you do Symfony mailer send, the email will actually be put in the queue instead of sent to your email provider, so that it doesn't block your user. And you can also retry the sending if it failed for some reason, like your email provider was down for a minute, or really anything, a network issue or something. Then you can handle retry on business critical emails, for example. And then now we talk about HTTP cache. And that just works out of the box with the server-side construct. We just add the add cache annotation, which says here that it's cached for 10 seconds. And this will work. And this can be 10 seconds, 1 minute, 1 hour, 1 day. But if you do a serverless deploy, the whole HTTP cache will be cleared. So you don't even have to think about this. It just works. And I know that most businesses today are running thanks to crontab. Without crontab, I think some businesses are in big trouble. And we can do something similar to crontab inside AWS Lambda. So here we have our console function, and we can just append an event, which is a schedule event, which says it's triggered at a rate of a cron expression. So here we say from Monday to Friday at noon. So every day at noon from Monday to Friday, we run the command bin console app list users -- send to Thibault@wid'op.com. And this is a command provided by the Symfony Demo, which lists the 50 latest users and sends them by email, because we don't care about GDPR, right? Okay, and now you need dev and staging and prod environments. Well, just one thing I didn't mention, of course, here you still have the 15 minutes time limit. So you can't actually run cron jobs like you always did and do batch processing for 5 hours every night. And you probably want to architecture it in another way, like sending messages to a queue or something if it takes a really, really long time. And also because we used to run cron jobs during the night, because it was just unused resources, right? Our website wasn't really used during the night, so we run the heavy processing during the night. But because process compute is on demand with AWS Lambda, we can run this cron job like every 5 minutes without it impacting our production workload, like our users browsing our websites, because it's totally isolated, and we don't have this kind of constraints. We don't need to do it during the night. The only reason you might do that is because you have the database, which would be heavily used by the cron job. But otherwise, there is no reason to run it during the night. Okay, and now you need dev and staging and prod environments. Let's get back to that. When I started, I said that there was this stage dev and that you didn't really needed to care about it. That's the moment we need to care about it. That's the default stage used by the serverless framework. And this is part of every resource deployed. So we have the service name and we have the stage name, and then we have the resource name, and all of that is concatenated. And so we can, with the serverless framework, specify this stage when doing a serverless deploy. So we can say serverless deploy -- stage equals dev. This will deploy to the dev stage. If we do -- stage equals staging, then we will deploy a brand new totally brand new staging environment, which uses the exact same configuration as our dev environment. If we do -- stage equals production, then it deploys the production environment. And now you have this marketing team in your company that comes to you and say, well, tomorrow we have a big event where we need to showcase our latest product, but it's not in production yet, and we don't want to use staging because there is a lot of tests going on, and we want something that is not used and really stable to do our demo and prepare our scenarios and things like that. Well, no problem. You just run serverless deploy -- save equals marketing demo. And the other day, when the event is ended and the demo environment is not needed anymore, you just run serverless remove -- stage equals marketing demo, and the environment is gone. And now you have your sales team coming to you and saying, well, we signed this big contract with a big corporation, and their only constraint is that they need a fully isolated environment where they are the only one to use it. That's an often needed thing when working with enterprise. And so that's what we call a single tenant application. And you can do that with the serverless framework by just running serverless deploy -- stage equals Acme Corp tenant, and you have a single tenant infrastructure. All right. And the last thing I talked about was I don't want to keep those ugly domains ending in .cloudfront.net. I want my own domain. And so let's say you and Irene here at Leeds PHP are really into serverless now because of this talk, and they want to host a blog for Leeds PHP. Well, they can just add to the lift constructs, so the website server-side website construct, a domain like blog.leedsphp.org with a certificate, which is so this is you need to create it in the AWS console and reference the ID, the identifier here. And there is documentation inside Lift and inside Bref, the Bref documentation to create this. It's just a few clicks in the AWS console, and you need to reference it here. And maybe you want multiple domains, like the bare domain and the 3W version. So here we are saying domain 3w.leedsphp.org and leedsphp.org. Both domains are valid. And we can even say redirect to main domain equals true. And this will actually redirect the all the domains listed here, we have only 2, but all the domains listed to the freew.leedsphp.org, the first one in the list. And make sure that your certificate here is covering both domains and not just a single one of them. And maybe you want to even use environment variables at this point to construct the domains. So here we have like freew.env domain name, which would be an environment variable that you put in a CI/CD pipeline or something, just to so that when you are doing serverless deploy --dev --stage equals dev, you have the dev domain, and when doing staging, you have the staging domain, the production domain, etc. All right, and now I think we are done. We deployed our code, hosted assets on the CDN, created a database, executed the migrations, stored the sessions, added Symfony Messenger and the queues behind it, scheduled cron jobs, enabled HTTP caching, deployed to multiple environments, and configured domains. And this looks like a real world PHP application, but hosted fully serverlessly, where you don't have to manage servers, don't have to manage the database, you don't have to manage the logs, etc., etc. And so we have a few benefits here. First, we have auto scaling built in, which is alone already awesome. We are only paying for usage and not uptime. We have high security and high availability because that is managed by our cloud provider now. We have less infrastructure to manage ourselves. We have easy deployment and replication of environments, so we can easily have staging and prod and dev and whatever environment we need. And as you saw, in something like 40, 50 minutes, we deployed a fully featured um, serverless PHP application. And that's thanks to Brefs, the serverless framework, and Lift, which allows us to have a quick ramp up to go quickly, but they are also fully extensible and ejectable. So you don't have to be using well, if they are too constrained at some point for you, you may just eject from Lift or from the serverless framework and use something else. And you also, and that's something I didn't mention earlier, is the fast major, minor, and patch PHP updates. That means, like in the past 4 months, I'd say when there was a PHP release, Bref was up to date within 2 days. So within 2 days, you have bug fixes, security fixes, new minor or major versions available. And I tweeted about this in August, where I said that Node.js 16 was released in April 2021, and there were at this time no support on AWS Lambda. And Python 3.9 was released in October last year, and it was only supported mid-August, so about 9 months later. And at this same time, the Bref PHP community was working on supporting PHP 8.1, which is not released, and it supported the release candidates almost from day one. And at each release candidate for PHP 8.1, Bref was released again within a few days, up to date with the latest PHP release candidate. So that's a really nice thing about Bref. You don't even need to update PHP anymore. That's done for you. Just run composer update bref, and it updates PHP at the same time. But there are also some constraints. First, we have the platform constraints like the 28 seconds HTTP timeout or the 15 minutes event timeout, which can be constraining for things like cron jobs or queue processing. We have the read-only and ephemeral file system, and we have cold starts, the added latency when Lambda is creating a new Linux environment. And one thing I didn't mention earlier is that the database is still a fixed resource. You are still paying for uptime. Um, and this can be a problem because the whole infrastructure scales infinitely because it's fully serverless, but the database is not serverless. So you have to provision it like you did before. You need to provision an instance, and you are paying for uptime here. And it's also a paradigm shift. So you are managing less stuff, and some people are not comfortable with this, and you are thinking more in terms of events instead of servers and resources. You are thinking about services. So it can be hard to transition for some people, and it's also best suited for greenfield projects, from new projects built from scratch with serverless in mind. And transitioning legacy projects to Bref and AWS Lambda can be quite a challenge for some people, especially if your application has long-running jobs that takes more than 15 minutes, or they have some other problems like they are heavily relying on the file system and things like that. It can be hard for them to transition to serverless. So yeah, better have to create a new project and have serverless in mind from the get-go. And as you saw, you can create a project, deploy it, and evolve the infrastructure at the same time as you evolve your project, and really deploy from day one. Like, you create your project, deploy it to AWS, and then you go from there and deploy your whole project on a regular basis. So my last word would be, just give it a try. Either it's for a Slack bot, or just a webhook, or some automation for things you have to do at work, or even if it's to build a REST API or a full-blown website like the the Symfony demo we used tonight. Just give it a try, test things out, and see if it works out for you. Thank you so much for coming tonight. And before I answer some of your questions, if you have, feel free to follow me on Twitter at T__Richard, and feel free to reach out on the Symfony and on the Bref Slack. I'm quite active there, so feel free to ping me or come into DMs, even on Twitter if you'd like. If you have some questions after the Q&A session, or drop me an email at thibault@wid'op.com. And if you if you are already using Bref or Lyft, or you liked what you saw tonight, feel free to start those projects on GitHub and share some love with the maintainers. Thank you so much.
Thanks for that, Thibault. That's very good. We had a talk.
Amazing.
We had a talk quite a while ago about Bref, and it sounds like it's come along quite a long way since then. It's exciting to see all the things you can do with it, and I was impressed by how slick that whole thing was, and how comprehensive it was, what you can actually do with it. It's very good.
Thank you very much.
So in terms of questions then, so first one that's come through is, do you have any advice on getting involved with open source projects?
Well, when I started contributing on open source projects, I think I started with just documentation. Like, I tried something with either Symfony or Bref, or really any project, it doesn't really matter. And I stumbled upon a problem. Then and it wasn't clear in the documentation how to solve it. Then I just made a PR to the documentation to cover this particular case, or just fix a bug you are getting in your application and that is blocking for you. I think that's the best way to get started. Don't try to get started with a big, huge feature that's taking months to develop, that wouldn't make any sense and would be quite frustrating, I guess. Just start with small things, do progressive enhancement on the projects you love, and yeah, I'd say that's the best way. It was the way I started, and worked out pretty well for me. And then I wanted to just do more. So yeah.
Sounds good. Question: are the slides for that talk available anywhere? People can have a look at them.
Yeah, I will share the slides shortly after the talk, probably on Twitter. So just follow me on Twitter, and I'll drop a link, and maybe I'll send them your way so you can put them in the meetup comments or something.
Yeah, and we'll retweet that as well. So if you follow Leeds PHP on Twitter as well, you'll get that.
Nice.
I don't think there are any other questions just yet. We'll give it another minute if anyone wants to ask anything. But yeah, thank you for talking to that. It was very good.
It was really, really good. Thank you.
Definitely want to go and have a play with some of that stuff now.
Yeah.
Yeah, and that's I didn't mention all the things Bref can do, but you can really deploy small atomic like controllers, if you like, using Bref and without a framework. So it can. We use this a bit at work to do some chatbots, for example, Slack bots, where you just deploy, like, it's 15 lines of PHP, drop it inside the Lambda function. You have a URL, you can give it to Slack, and they handle the rest. It's quite awesome to be able to build even just small automation features, Slack bots and webhooks and things like that. Just a few lines of PHP, and drop it in AWS. You don't really have to care about it for almost the rest of your life because it's fully managed. That's quite nice too.
Yeah, it takes a lot of the overhead that you have to think about, doesn't it, for managing resources and stuff like that. It's good to just let AWS do it.
Yeah, and the last thing is this database, because it's not fully serverless, so you still have to manage it and guess what the correct amount of memory and CPU is and things like that. And folks at AWS are currently working on this. So they announced last year a service called AWS Aurora Serverless, which is more or less like Lambda for a database, but you're still paying a bit for uptime. It's a bit weird, but it's going in the right direction to have a SQL database running in a serverless fashion. And if you just need a little database, you can use DynamoDB, which is an AWS service, which is fully serverless, and you only pay for what you use. So it can be an alternative, but DynamoDB is a bit confusing for us developers used to SQL, right? Because it's NoSQL and just also a paradigm shift in itself. So, but yes, the database is the last missing piece, I guess. There are also competing services in other cloud providers or standard products that offer serverless SQL database. You can take a look at that too if you really want one. But yeah, that's the missing piece, really.
Cool. And Bref's just AWS, isn't it, for the moment?
Yes.
Cool. That's really good. We haven't had any other questions, so I think we'll call it there. But thank you again for sharing that talk again tonight, and thanks everyone for tuning in. See you next time.
Thank you.
Thank you.
See you next time, everyone.